All right, we're going to simplify complex fractions now. A complex fraction sounds scary, but it actually just means that we have a fraction inside of a fraction. Now, these are going to look a little creepy, but we'll get through this. I'm actually going to teach you a way to kind of skip to getting rid of them right away, which would be very really easy to do. Now, I know fractions can be stressful for students, so we will try to get through this. So our first example, we're going to have 3a over 25b squared. All of that is going to be over one big fraction, 9a squared over 5b. Now, what I need to do is I need to look at these two fractions and decide between the 25b squared and the 5b, what is the LCD, or the least common denominator? And I'm going to decide, I think that that's 25b squared. So what I'm going to do is multiply the numerator by 25b squared. And in the denominator, with the 9a squared over 5b, I'm also going to multiply 25b squared. Technically, what I'm doing is I'm just multiplying the top and bottom by 25b squared. Notice it would still reduce out if I wanted it to. But I'm going to view the numerator, the big numerator, as its own piece. And I'm going to notice that the 25b squareds actually cancel. They reduce out completely. And I'm left with 3a. Down below, 9a squared over 5b is going to reduce, the 5b is going to reduce with the 25b squared. A 5 is going to come out of the 25. And the b squared over b just becomes b. Now I know this looks a little messy, but I end up with 9a squared times 5b. Multiplying that out, I end up with 3a over 45 a squared b. All right, notice we knocked out those big crazy fractions. Now I still need to try to reduce this one. I'm going to notice that the 3 is going to reduce with the 45, and the a is going to reduce with the a squared down below. Now 3 into 45 is going to give me 15. So up top, everything is gone, so I'm going to be left with a 1. Down below, the 3 over 45 became the 15. The a over a squared just became a. And the b is just kind of hanging out. Now, notice the 15, the a, and the b have to be in the bottom. It does matter. If everything in the numerator reduces out, we're left with a 1 on top. We got to keep it all on the bottom. And that's our final answer for this problem, 1 over 15 ab. Next problem. We have 6x over x minus 5 all over 12 over x plus 5. Now, up top and down below, the two fractions that we have, the denominators are x minus 5 and x plus 5. Now, it kind of looks like they're similar, but they're actually very, very different. So the LCD in this case is going to be big and ugly. So up top, I'm going to have 6x over x minus 5. And the LCD is going to be x minus 5 times x plus 5. I know that's a big chunk there, and it's a little overwhelming. Down below, I have 12 over x plus 5. And again, I'm going to multiply that by the same thing, the x minus 5, x plus 5. Has to be the same. Notice they would reduce out as 1s if I needed to. But instead, what I'm going to do up top, I'm going to notice, and I'm just looking at the big numerator, that the x minus 5s will actually reduce. And I will be left with 6x times x plus 5. And that takes care of that big numerator. Down below, in the big denominator, the x plus 5s are gone. They reduce out completely. I'm left with 12 times x plus minus 5. I'm going to notice that the 6 and the 12 actually reduce. Let's move with a 2 down below. I end up with x, parenthesis, x plus 5, all over 2 times x minus 5. Now, I know it's tempting to reduce the x plus 5, x minus 5, or maybe in there, but we can't. This is actually all the further that we can go, and this is our final answer here. Next example. We're going to have x over y squared plus 1 over y all over y over x squared plus 1 over x. Now this one is messy. We've got 4 little fractions, and we have to find the LCD for all 4. So looking between y squared, y, x squared, and x, it looks to me like our LCD in this case is going to be x squared times y squared. Remember, it has to be the same for both. I can't just find the LCD for the top only. It's got to be between all of the little fractions. Down below, I have y over x squared plus 1 over x. That should just be x there, yeah. And now I'm going to have that also x squared times y squared. Notice the x squared times y squareds could reduce, but instead I'm going to distribute them into their associated parentheses. X squared, y squared times the first one. Notice the y squareds reduce completely, and I'm going to be left with x times x squared. That's going to be plus. Now when I multiply the x squared times the 1 over y, x squared, y squared times the 1 over y, one of the y's are going to reduce, and I'm going to be left with x squared times just y, because one of the y's are going to cancel. Technically, that's 1 times that because of the numerator, but we're not going to write the 1 times there because we don't need it. Looking in the denominator, the x squared, y squared times y over x squareds, the x squareds are going to reduce, and I'm going to be left with y times y squared. Plus, now I'm going to go x squared, y squared times 1 over x, and one of the x's are going to reduce out. I'm going to be left with x, y squared. This one is messy. Cleaning up the numerator, x squared times x is just x to the third, plus x squared y over y to the third, plus xy squared. Now, like with any fraction, I need to always try to reduce it. And I'm going to notice up top I have a greatest common factor of x squared. And I'm left with x plus y. Down below I have a common factor of y squared. And I'm going to be left with y plus x. Now, x plus y plus x, they're actually the exact same thing. For the same reason that 2 plus 3 is 3 plus 2. So the x plus y's reduce completely. And I'm left with x squared over y squared. And I can't go any further with that. They're different letters, so that is my final answer.